Hello my dear students, welcome back to the session. The last class we discussed question number 1 classroom workbook in application of Laplace transformations. Now let's look at the question number 2 in the similar lines. Find I of t for t greater than or equal to 0. Is of t is given 4u of t plus 2 dou of t, impulse and step combination is given, and asked to find what is the current flowing through this inductor. Okay, that is I of t. Time response. So time response, whenever it is asked, we have two approaches. Okay, first we have to see the category. Is it first order or second order? First order, but it is excited by what? Combination of step and impulse. Okay, therefore definitely it cannot be solved by the formula. We have to go for S-domain approach only. Yes or no? Therefore this S-domain approach, when we see here, first let us construct S-domain equivalent. To construct S-domain equivalent, you must know what is the current flowing through the inductor at t equal to 0 minus. Did he give any information? No. Is there any facility to find that current through the inductor at t equal to 0 minus indirectly? No. Switching operation is not given. He did not mention what are the initial conditions, 0 minus conditions. Then obviously you have no other option. Okay, you have no other option other than assuming IL of 0 minus is 0. That's it. Okay, he has not given, and there is no possibility to find those values. Okay, the current through the inductor at t equal to 0 minus. Therefore, I can assume it to be 0. Now let's construct S-domain equivalent circuit. What do you get here? Just a minute. Excuse me. So therefore, this particular one can be determined by constructing an equivalent, S-domain equivalent. Here I can find this value. Now what is this actually here? 0.2s, 1 ohm, 2 ohm. What about this? Here 4 by s plus 2. Yes or no? 4 by s plus 2. Then what is this actually here? Now this is going to be I of s. I of s. Now I of s will become opposite. These two are two parallel paths. Yes or no? One parallel path is consisting Z1, the other parallel path is consisting Z2. Okay, the current flowing through Z2 is nothing but opposite impedance Z1 by Z1 plus Z2 into 4 by S plus 2. Is it clear? Let us try to simplify it and find that I of s here. Okay, I just give you directly that value. This will become this will become 180 s plus 360 by 9s s plus 15. Okay, actually you get this you get actually the value like this. (20s plus 40 by s into s plus 15). So you can find a by s plus b by s plus 15. According to method of residues, a can be calculated. S is equal to 0, 0, 0, 0, 40 by 15. 40 by 15 is nothing but what? 40 by 15 is nothing but what? What do you get actually here? 40 by 15 will give you 5 8 ja, 5 3 ja. So what do you get? 8 by 3 by S. Okay, sorry, 8 by 3 only, right? 8 by 3. This is nothing but what? 8 by 3. Similarly, B value. S is equal to minus 15, minus 15, minus 15, minus 15. Okay, if you solve that, you will get a value of, I just give you 52 by 3. 52 by 3. So therefore, now I of t will become 8 by, okay, 8 by 3 by S plus 52 by 3 into e power minus 15t. This is what the total response, okay, you will get. Understand all of you, okay? So this is how you can solve the problem using S-domain approach. It is very simple. First you find S-domain response, then you find the time domain response, okay? So please note down that, and also you can go for this third problem here, find V naught of t, okay? Please quickly note down that. Let's go for third problem. Let's go for third problem here. According to S-domain equivalent, you can get the circuit like this. 1 by S, 1, 3 by S, 5 ohm, 1 ohm. What is this? Yes, okay. Now, initial conditions are not mentioned. 0 minus conditions are not given. Switching operation is not given. So you can assume that, okay, you can assume that V naught of, okay, sorry, Vc of 0 minus is 0, and IL of 0 minus is also 0. Because he has not given the values of 0 minus conditions, he has not given even switching operation. We have no other option. You have to assume them 0, because directly or indirectly the values are not given. So that's why I'm just directly taking here, and I would like to find the value of V naught of S. That's the question actually here. What is the question actually he's asking? What is V naught of S? Okay, so first let us try to find here using node analysis. What is V of S? V of S can be determined using node analysis. 1 by 1, 1 by 3 by S plus 1 by 5 plus S is equal to 1 by S by 1. From this, you find what is V of S, and then you find what is V naught of S. What is V naught of S? Once you know V of S here, S by S plus 5, because these two are in series, yes or no? When you have series, then you can apply voltage division rule, and then you can find what is V naught of S into V of S. So what are the value you get? You substitute here, you get the value of what? V naught of S. I can give you directly that final value, but you need to calculate all those things, okay? Please calculate all those things clearly, but the final answer you can check with, this must be 3 by S square plus 8S plus 16. The answer is supposed to be, okay? So once you have this, you need to go for a L inverse, right? For finding L inverse, what is V naught of t? Okay, before that, let me bring that entire thing into convenient form, okay? Into convenient form, that is 3 by, Okay, I can say s square plus this is 2 into 4, right? 4. 2 into 4 I can say. And what is the 16? Yeah, it is 16 actually here. Now 2 into 4 and 4 square, you can say 2 into 4 into s plus, this is 18 actually, okay? This is 18. And you can say 18 can be written as 4 square, that is nothing but 16 plus 2. Okay, this is 18 actually here. Now 3 by, you can write s plus 4 whole square, yes or no? This part can be written as plus 2. Now this can be written as root 2 whole square, yes or no? Now 3 by root 2 into root 2. For finding L inverse, this is more comfortable, right? This is more convenient. So root 2 whole square. That's it. Now inverse Laplace transformation of V of s will give you, okay, what do you get here? 3 by root 2. Look at this. S plus a whole square plus omega square, omega by. Therefore, e power minus 4t sine, what is this? Root 2 t. This is very important. The answer is 3 by root 2 e power minus 4t sine root 2t. This is what your final answer. Please note down. Note on that. Meanwhile, I just note another problem. Question number 4. Question number 4. If V naught of 0 is 5 volts, then V naught of t is how much? Ten e power minus t u of t, 10 ohm, 10 ohm. Here is a capacitor across which the voltage is asked to find, 0.1 farad. This is 2 dou of t amperes. Okay, this is in volts. Now he's asking what is V naught of t. First of all, whenever the problem is given, I told you already, you have to check two conditions. What is the input excitation? Okay, what are the inputs that you have? Is it step or other than step, anything that you have? Yes, you have exponential and step. Now, irrespective of the order of the system, definitely you have to go for what? Second method. This comes under second category. Therefore, you can solve it using only S-domain equivalent approach. Yes or no? Okay, all of you. So therefore, let us do it using S-domain equivalent approach. And to draw the S-domain equivalent, definitely the voltage across the capacitor must be known. But here the switching operation is not given, but he mentioned what is that zero condition, zero minus conditions, okay, in the capacitor that is 5 volts given. So therefore, let me draw the equivalent circuit here. Plus minus. Now, a series capacitor model, I am replacing it by, what is that value? 5 by S. 0.1 farad, nothing but 10 by S, 1 by CS, right? This is 2 only, because dou of t as domain is equal to 1, right? 10 by S plus 1, 10 ohm and 10 ohm. Now this entire value is V naught of S. This is 0. Therefore, you can take it as V naught of S. Now, V naught of S of 1 by 10, 1 by 10, 1 by 10 by S. Okay? Yes or no? Is equal to 2 amperes plus 5 by S by 10 by S. Here 10 by S plus 1 by 10. Yes or no? 10 by S plus 1 by 10. Like this. You can go for, this is V naught of S. Okay? Let me give you directly that value. You have to find, okay? All of you. You have to find, you have to simplify it. Okay? I cannot really simplify it. It will take a lot of time. But you need to do it, because in the exam, if you don't have a practice, I'm sure that you will do mistakes. You need to have a lot of practice in finding these S domain response and L inverse of it. Okay, you must be very careful in finding those values. So 25S plus 35 divided by S square plus 3S plus 2. Okay. Now, if you find the partial fractions A by S plus 1 plus B by S plus 2, because this one you know very well, S plus 1 into S plus 2. So A is equal to, can be determined here. A is equal to minus 1. So minus 1. That means 1. Minus 1. That means 10. So therefore 10. B is equal to minus 2. Minus 2. That means minus 1. Minus 2. Minus 2 means minus 50. Minus 50 plus 35. Minus 15. But minus by minus plus. Therefore plus 15. That's it. Okay. So you got 10 and 15 here. Therefore the V naught of T will become L inverse of V naught of S. Therefore you will get 10 e power minus T plus 15 e power minus 2T. This is what the response you got. Okay. So please note down. Note down that. Meanwhile, I can just give you another problem. Quickly note down. Question number 5. Question number 5. Here the switching operation is given. Okay. So the values here 1 by 4 farad, 1 Henry, 2 ohm. This is also 2 ohm. T equal to 0, the switch is open and the voltage source value is 2 volts. Now let us read the question carefully here. On closing switch S, the circuit in the given figure is in steady state. The current in the inductor after opening the switch S will, option A, decay exponentially with a time constant of 2 amperes. Option B, decay exponentially with a time constant of 0.5 second. Okay, first one is with 2 seconds, second one is 0.5 second. C, consists of 2 decaying exponentials with each with a time constant of 0.5 second. Option D, be oscillatory. Okay, so that means what? You need to comment on the nature of the response. If you want to comment on the nature of the response, definitely you must have a response, time response. Now what is the procedure to find time response? Again, you have options. What are the options again? Formula and S domain. But look at this, is it first order or second order? Inductor and capacitor both are there, therefore definitely it is a second order. But of course stepping excitation is there, but it doesn't matter. When it is a second order, you have to go for S domain equivalent only. S domain equivalent. To find S domain equivalent, you must know IL of 0 minus and VC of 0 minus. Okay. He has not mentioned, but he has given switching operation. Can you find or not? Yes or no 0 minus conditions can be determined or not? Yes, I can determine. What is that IL of 0 minus? IL of 0 minus, I am not drawing that circuit because we have crossed that stage. You need to analyze it on your own easily without drawing the circuit. Switch closed condition 0 minus. You're opening it, t equal to 0, closed condition, short, open. If it is short, the entire current is passing. So 2 volts by 2 here, 1 ampere. And 2 into 1, because this is shorted, the voltage across 2 ohm will give you the voltage across capacitor because it's acting like open circuit. Therefore, Vc of 0 minus is 2 into 1, that is 2 volts. Now let me draw the equivalent. The equivalent must be drawn for what? T greater than 0. That means switch is opened. Finally, you are left with. Okay, the current was found like this. The voltage was found like this with the polarities and directions clearly. Now I indicate clearly here the inductor 1 into S, that is S. This is 2 ohm. And based on the direction of the current that you determined here already, you get polarities minus plus. You remember all of you? So 1 into IL of 0 minus, that is 1 volt. Now, this is resistor and capacitor and the voltage source plus minus. What is this value? 2 by S, 4 by S, okay? 4 by S, and this is 2 ohm, and this is what actually the current. What is it current actually here? IL of S. He is asking what is the current through the inductor. The current through the inductor or current in the inductor after opening the switch S will be, he is asking. Okay. So let's find that current here. So what you get IS, let me write it here. IL of S, total voltage by total impedance, right? So 1 plus 2 by S by, what do you get? 2 plus S plus 4 by S plus 2. Okay. S plus 2 by S, S square, 2 plus 2, 4, 4S plus 4 by S. S gets cancelled. S plus 2 by S plus 2 whole square cancels. 1 by S plus 2. Therefore, IL of t will become e power minus 2t. Time constant is how much? 1 by 2, that is 0.5 second. So it is an exponentially decaying function. Exponentially decaying with a time constant of what? Time constant of what? Okay? Time constant of 0.5 second. The time taken for the response to reach, okay, 36.7% of its initial value. Okay? 36 point you got here. It's the time taken for the response to reach note down that quickly. Meanwhile, I just note another problem, question number 6. Question number 6. It was actually asked in GATE, IES, okay? Previous problem was also asked in IES. Ten volts, t equal to 0, I of t, 1 ohm, 1 Henry, 1 ohm, 1 farad. He's asking what is I of t for t greater than or equal to 0. Okay. I think you have finished that. Now let us look at this. Is it a first order or second order? No doubt it is a second order, right? Second order, and is asking what is I of t. Definitely let's go for S domain equivalent. For S domain equivalent, current through inductor t equal to 0 minus, you need to find. Here also Vc of 0 minus. But switch is initially open. Can you charge this? No. You can't charge both of these, right? Therefore, IL of 0 minus will be definitely 0. Vc of 0 minus is also 0. Therefore, for t greater than 0, the S domain equivalent circuit will be something like this. Since there is no 0 minus current, voltage source doesn't come. That's value is 0. Yes or no? So S 1 ohm, 1 ohm, 1 by Cs. That means 1 by S. Here the voltage source value is 10 by S. Now he's expecting here, this is I of t actually required, but I of S let us find first. These two are in series. That means its value is how much? 1 plus 1 by S. Nothing but S plus 1 by S. Okay. Now this one is how much? 1 plus S. Now both are in parallel. So the total impedance is 1 plus S into S plus 1 by S divided by S plus 1 plus S plus 1 by S. Okay. This is what actually Z of S. Okay. Okay. So Z of S will be equal to, now what do you get here? So this is S into S plus 1, right? This is S plus 1 whole square by S. Now S into S plus 1, therefore S plus 1 you can take it common. Okay, so S plus 1, if you take it common, what will happen here? Look at this, all of you. Okay, you can take S plus 1 into S plus 1 by S plus. Yes, S plus 1 plus S plus 1 by S. So what do you get here? S plus 1 whole square by S by S into S plus 1. Okay, plus S plus 1. So if you take S plus 1 common, both divided by what? Again, by S. So this will get cancelled. S plus 1 whole square by S plus 1 whole square by, what do you get? Okay, S plus 1 if you take common, again you get what? S plus 1. So got cancelled completely. So Z of S you will get 1. Then what is that I of S here? 10 by S by 1. 10 by S. What is I of t? Nothing but L inverse of I of S. Nothing but just 10 ampere. So what is happening here? The current is independent of time. All the time the current is 10 amperes. Constantly it is flowing. Okay, the time response itself is 10 amperes here. Okay, so note on that. Sixth problem. Sixth problem, note down, which was asked in IES. Meanwhile, I just remove this part. Question number 7. C1 is equal to C2 is equal to 2 farad, and the capacitor C1 was charged to 20 volts. Then he's asking what is Vc2 of t. Now this is Vc2, Vc1. Now what is he asking? Okay, Vc2 of t. Vc1 of 0 is 20 volts. He is asking what is Vc2 of t. And he has given 4 options. Fixed voltage of 20 volts, fixed voltage of 10 volts, fixed voltage of minus 10 volts, option D, sinusoidal voltage. So let us see that. Let us see that. I think all of you noted down this, right? Let me remove it. So can you make an attempt? All of you can try, right? Right. Now we can see the response here. S domain equivalent because there are 2 capacitors, 1 inductor, definitely there is no other option. But t greater than 0. I think all of you gone through the question, right? Clearly. In the circuit shown in the given figure, C1 is equal to C2 is equal to 2 farad. And the capacitor C1 has a voltage of 20 volts with the switch open condition. That means initially the switch is open, at t equal to 0 it is closed. By looking at the circuit you can understand. Okay, when it is in open condition the VC1 was 20 volts. He did not mention anything about VC2. That means it was initially uncharged. Okay, it was uncharged capacitor, whereas C1 is a charged capacitor. Very clearly understood from the data given. If the switch S is closed at t equal to 0, the voltage Vc2 will be some 4 options given. Okay, so first let us draw the S domain equivalent and then find the time response. We can easily understand. T greater than 0, then what is the equivalent? Ls, he did not give any inductor value. Switch closed, nana. What is this? 1 by C2S. He did not give any value of the voltage across C2. Vc2 of 0 minus was not given. But he gave Vc1 of 0 minus. What was that value? 20. So 20 by S. What is this? 1 by C1S. That's it. Now you are expected to find Vc2 of S. Then Vc2 of T. Okay. So what is that? Actually you can find. Tell me. Vc2 of S is nothing but 1 by C2S divided by Ls plus 1 by C1S plus 1 by C2S into 20 by S. Yes or no? Okay. So what do you get here? You get, if you simplify this, okay, what do you get? Tell me. 1 by C2S by L C1 C2 L C1 C2 S square plus 1 plus 1, okay, then divided by C1 C2 S square, yes or no all of you? C1 C2 S square into 20 by S. Getting all of you? Okay. So what do you get here? C2 gets cancelled. S get cancelled. Yes or no all of you? Okay. S get cancelled. Finally this S will become numerator. Come into numerator. That S and this S will be cancelled again. Finally you are left with what? Now in the numerator 20C1 divided by L C1 C2 S square plus 2. Okay. So therefore, Vc2 of S will be 20 C1 by L C1 C2 S square plus 2. Then again 20 by, you take L C1 C2 common, then L C2 divided by S square plus 2 by L C1 C2. I think you understand now here. Can I express 20? Okay, because this is, you call it omega, then root omega. Yes or no, all of you? Okay, then root omega whole square if you can take. Understand all of omega square, because I want omega square, right? Omega square means what actually here? Root of this value and whole square you can take. So 20 by LC2 into, okay, root 2 by root LC1C2 into root LC1C2 by, okay, root 2. So this is what actually you can try for. Then S square plus root 2 by LC1C2, okay, whole square, you can put it. So it's very clear that some value, some constant is there. You can say this is some constant K. Okay, this you call it omega by, what do you get? S square plus some omega square. Yes or no, all of you? What is this actually? You get here K times now sine omega t or not? So what is that omega? You know very well. This value root 2 by root of 2 by LC1C2, and what is K? You know very well. 20 by LC2 into root LC1C2 by root 2. So therefore you got a sinusoidal response. So out of 4 options given, fixed voltage 20 volts, fixed voltage 10 volts, and so on. But option D is given as what? Sinusoidal voltage. I can go with option D. Option D is the correct answer. No doubt, all of you? No doubt. Meanwhile, I can just note another problem here. Just note on that. This problem was asked in GATE. I think all of you understand the simplification part. So inverse Laplace transformation is very, very important. I told you already multiple times that you must be expertise in finding inverse Laplace transformation. So I'm just noting down another problem here. I think you have done this part, okay? You have noted down the problem, right? So read the question here, 8th one. In the following figure, C1, C2 are ideal capacitors. C1 has been charged to 12 volt before the ideal switch S is closed at t equals 0. The current I of t for all t is. So current I of t for all t, that means he's asking the time response. Okay, he is asking what is I of t. That's it. Okay, so therefore, how do you find? There are 2 capacitors. Okay, there is no resistor to find the time constant. Therefore, you have to go for S domain equivalent. First formula, that formula doesn't work here. Okay, therefore, for t greater than 0, you know that 1 by C1 S, and what was the voltage given? Actually 12 volts, right? So the voltage across the capacitor was given what? 12 volts, right? So therefore 12 volts, this is 12 by S. Switch was closed, right? For t greater than 0, 1 by C2S. Okay. Now what is expecting here to find this? Okay, I of s. So what is I of s? I of s is nothing but 12 by s by 1 by c1s plus 1 by c2s. So ss gets cancelled and 12 c1 c2 by c1 plus c2. Right? This is 1. So I of t can be written as now 12 c1 c2 by c1 plus c2 of dou of t. That's it. So what is that? 0, a step function, an exponentially decreasing function. Option D, an impulse function. Yes, option D is correct. Okay, let's look at another problem. Please note down that. Note down that. Meanwhile, I just give you another problem. Question number 9. It's a very interesting question. Question number 9 was asked in GATE. Very interesting question. A square pulse of 3 volts amplitude is applied to a CR circuit shown in the following figure. The capacitor was uncharged. The voltage, the output voltage V2 at time 2 second is V2 of 2 is asking. Okay, CR circuit he has given. Okay, he has given a CR circuit, 0.1 microfarad, 1 kilo ohm, expected to find V2 at time 2 second. Okay, this is what the problem given. When these kind of problems are given, first of all, you have to understand here, okay, what is the normal approach, and then we see what is the different approach that we have to save time. First, let us look at the actual procedure. Then we will look at, is there any opportunity to solve this problem without using a lengthy procedure. First, I'll discuss lengthy procedure. Okay, look at this. See, whenever this input is given, what is this input actually here? It is a step input, but it has shifting function. Yes or no? So 3 into, we can say u of t minus, what is this? Yeah, u of t minus 2. Yes or no, all of you? What is this actually here? U of t minus u of t minus 2. Yes or no, all of you? This is what actually the step function with some shifting. Now, whenever there is a shifting, okay, time shift is there, definitely that first formula doesn't work, because though it is a first order system, because this is having a shifting, time shifting function input, though it is a step input, but with a time shift, therefore that doesn't work here. You have to go for S domain equivalent only. So now you have to find S domain equivalent of this, then capacitor uncharged he mentioned clearly, then okay, you have to convert this into S domain, then these two are in series, then what is the impedance across this? Z2 by Z1 plus Z2 into V1 of S. Okay, what is V1 of S? This is what actually V1 of S, that means V1 of t you can find, then V1 of S domain you have to convert, then you have to find inverse Laplace transformation. This is what the procedure. So I don't want really, if I prefer this method, I'm sure that it is going to take a lot of time. So I don't want to prefer this method. Okay, before I apply this method, let me check if the problem is given in my convenient form. Probably I can avoid this S domain equivalent and simply I can solve using a common sense. Look at this, all of you. Look at this, all of you. The step input is given to this RC circuit. As soon as step is given, what will happen? The capacitor gets charged. Yes or no, all of you? Okay, the capacitor gets charged. The charging voltage or the voltage across this capacitor depends on, okay, the time constant. Yes or no, all of you? The time constant will decide how faster the capacitor will get charged. Now, my objective is, actually I would like to see whether this time constant, what are the time constant that I calculate? Okay, what are the time constant that I calculate? What is the time constant actually here? Let me calculate time constant first. If I calculate time constant here, what is the value? 0.1 microfarad, 10 power minus 6 into 1 kilo, 10 power 3. So that means 0.1 microsecond. This is what the time constant. But what is the pulse duration you have given? Up to 2 seconds you have given. That means the voltage across this network is given up to 2 seconds. Okay, at 2 seconds instantaneously the value of this V1 is coming down to 0. Okay, now you compare this tau and the time. When you compare the tau is very much less than the duration of this particular pulse, that is 2 seconds. It is clearly understood that, okay, before this 2 seconds, much in advance to this 2 seconds itself, the capacitor got charged to the full voltage or not? Yes or no, all of you? Because the time constant is what? 0.1 microsecond. Within this 0.1 microsecond itself, the voltage across the capacitor, what is the time constant definition? It's the time taken for the response to reach 63.2% of its final value. What is the final value? 3 volts. So within this 0.1 microsecond, if it reaches 63.2% of final value, then before it reaches to the 2 seconds, definitely that would have gone to what? 3 volts. Yes or no, all of you? 63.2% of final value it has reached at the time 0.1 microsecond. Then at time 2, what will happen? The capacitor would have definitely got charged to what? The full value, that is 3 volts. Now I understand that at 2 seconds, I know what is the value of V1, that is coming down to 0. I know what is the voltage across the capacitor, that is charged to 3 volts. That means at time t equal to 2, I can comfortably construct the equivalent circuit. So whenever these kind of problems are given, instead of going for S-domain approach, or before you go for S-domain approach, just cross-check once. What is the duration of the pulse and what is the time constant of the given circuit? If the time constant of the given circuit is very much less than the pulse width or the duration of the pulse, I am sure that at this particular instant you can construct the equivalent of the given circuit. Now let me construct directly at t equal to 2, the equivalent circuit will be, what is this V1 of 2 nana? It is 0, coming down to 0, yes or no? So therefore voltage becomes 0, nothing but what? Short circuit. So V1 of 2 is equal to 0. Now the capacitor is charged to how much voltage? 3 volts. Okay, Vc of 2 is equal to 3 volts. On what basis you decided here? Because tau is very much less than the duration of the pulse. Okay, so it's a very, very interesting problem. You can easily solve. I'm sure that even if you go for S-domain, you can get it, but let us not hover valuable time in finding S-domain, then time domain. Yes or no? It will take a lot of time. So now, what is this value? Now you got an equivalent at t equal to 2. This value is 0. This is 3 volt. Now you can find what is this value. V2 of 2 is nothing but what? This is plus, this is minus. So with opposite polarities, you would like to measure the voltage. Therefore, V2 of 2 is equal to what? Minus 3 volts. That's it. You understand? Okay. So this is how you need to solve the problems. It's very simple and interesting problem. Okay. You have to check first, what is the time constant of the given circuit and what is the pulse duration? The square pulse is given. What is the duration of it? First you compare. Okay. First you compare. If the time constant is very much less than, if the time constant of the circuit is very much less than the duration of the pulse, it clearly indicates that the capacitor gets charged to the full voltage before, okay, before the end of the duration of the pulse. So once you know the voltage, at the given instant, okay, at the given instant, then you can replace this capacitor by, because already you know how much the capacitor got charged to, so therefore you can replace this entire circuit by, okay, entire circuit by its equivalent at t equal to 2 seconds. At t equal to 2 seconds, we know the value of the voltage V1, because V1 is coming down towards 0 at t equal to 2 seconds, and voltage across the capacitor is charged to full voltage, okay, and therefore I have constructed the equivalent like that. Okay, so instead of going for the S domain equivalent circuit, I'm able. So I stop the session here, my dear students. I continue with some other different problems in the next session. Okay.